Hey guys, welcome to our first week of actual distance learning with new material. What we're going to start today is our rational expressions unit. And you talked a little bit about rational expressions last year when you talked about factoring. So this is going to actually pick up with a brief review of something that you did last year. And then next week we'll start looking at some newer concepts. So last year, when you talked about simplifying rational expressions, you were reminded of this definition that you see here of what is a rational number. And a rational number, remember, is a quotient of two integers. But that's really a technical way of saying that. In basic English, we usually just think of a rational number as a fraction. And we know from earlier math classes that when we have rational numbers or fractions, we can reduce them. So when we say simplify a rational number, we simply mean reduce the fraction. Now, I'm sure that we all know how to simplify 8 over 22. Think about it for a second. 8 over 22 should reduce, in this case, to 4 over 11. Now, the question is, how do I know that it's supposed to be 4 over 11? And the idea is that we're dividing each of the numbers here, the numerator and the denominator, by a common factor, meaning in this case, both 8 and 22, since they're even, can both be divided by 2. But really, when we say we're dividing by 2, the other way we can think of this is 8 and 22, they share 2 as a common factor. 8 is 4 times 2, and 22 is 11 times 2. So when we say that we're going to divide them, we're actually canceling out the 2's here. So that's how we're getting the 4 over 11. And we know that if I have something where I have just numbers, I can reduce them that way. When we talked about our exponents unit, we also saw that rational expressions, where we have polynomial fractions, meaning variables in both the top and the bottom, we can do all the same things that we do with regular numbers, which means I can actually simplify the 4x over 11x the exact same way, because in this case, 4x and 11x, those are multiplications, 4 times x, 11 times x, which means x is a common factor between the top and bottom, and that would also simplify or reduce to 4 over 11. One of the things we did not talk about in our exponents unit, but you might have talked about last year in factoring, is that when we talk about simplifying these variable expressions, it doesn't matter if I have a monomial like I had in the last case, or if I have something like here in number 3, 4 times x plus 3 over 11 times x plus 3. In this case, my common factor happens to be the entire quantity of x plus 3 in both the numerator and the denominator. So guess what? If I want to simplify this, the common factor cancels out, which means the x plus 3's cancel, and that leaves us with just 4 over 11. All right, so let's get into something a little more complicated. Let's suppose instead of having just the 4 and the 11 multiplying a quantity, what if I had two quantities in both the numerator and denominator? Here I have x plus 3 times x minus 1 over x minus 1 times x plus 1. In this case, I really have 4 different factors that I'm looking at. The 4 factors would be the two quantities in both the numerator and the denominator. So I have the x plus 3 as a quantity, I have the x minus 1 as a quantity, the x minus 1, and the x plus 1. And in this case, those quantities represent the factors. So if I look at what is common between both the top and the bottom, you can notice that I shaded both the x minus 1s the same color because those are in common, which means those whole quantities will cancel each other out, leaving us with a numerator now of x plus 3 and a denominator of x plus 1. So our final answer for simplifying this fraction is x plus 3 over x plus 1. Now you might be saying, wait, can't I go a step further and simplify something else? Well, let's think about this. If I had 20x plus 25 over 2, would I be allowed to say that this simplifies into 10x plus 25? Because 20 over 2 is 10 over 1. The answer is no. I would not be allowed to do that. if I were to actually think about what this fraction represents, if I wanted to split it up, I would have to take 20x over 2, but I would also have to take the 25 over 2 to get 10x plus 12.5. So I can't cancel out the 20x and the 2 by themselves. I would have to also consider that second part of the numerator. In other words, when we cancel, we are canceling factors, which are the entire contents of a set of parentheses. I cannot cancel just terms. Those would be the numbers that are being added or the things being added inside the parentheses. So if I look at a case here, if I had 3x plus 1 over 3x plus 1, when I put parentheses around the 3x plus 1s, notice how everything is exactly the same in both the top and bottom. So those two quantities cancel out, and that does indeed leave us with 1. That would be the proper way of canceling out. If I would try and do that with, say, the second example here, 3x plus 1 over 3x plus 2 equals 1/2. When I put parentheses around those, notice how the 3x plus 1 and 3x plus 2 are different quantities. I cannot just cancel these out and say that it is 1 over 2. So we want to make sure that we are being careful here. I'm only allowed to cancel out entirely equivalent quantities, not just certain terms. So let's go back to simplifying. Let's say we had 4x plus 12 over 11x plus 33. At first glance, I might look at this and say, oh, I can't do anything, it's simplified. But the reason that we talked about this last year in factoring is because the key here is right now I just have terms. I have things being added in the numerator, I have things being added in the denominator. But if I take them and I actually try and break them into factors, I would look at the numerator, 4x plus 12, and I'd say, oh, that's a GCF. I factor out a GCF of 4, and I have x plus 3 left over. In the denominator, I do the same thing. I look and say, oh, 11x plus 33, that's a GCF as well. I can factor out the 11, and I'm left with x plus 3. And now I have a common factor. The quantity x plus 3 is the same in both the top and the bottom. They cancel out. And magically, it's as if I planned it this way. We are left with 4 over 11 again. Amazing. All right, so this is simplifying rational expressions. In order to simplify a rational expression, it's basically 2 steps. We're going to factor both the numerator and denominator if necessary so that we're able to cancel. And the key here is when we say factor, we're going to use any method possible. So we're going to use any method. That means we're going to want to use GCF. We might use reverse FOIL. We might use difference of squares. Probably not factoring by grouping, but maybe even factoring completely. Factoring out that GCF and then reverse FOIL or difference of squares. At this point in the game, we should be always planning on factoring completely, meaning look for a GCF, then start looking for those other factoring methods. Second step, once we've factored, is you're going to cancel out the common factors in both the top and the bottom of the fraction. So let's look at number 7. We have y squared minus 9 over y squared plus 6y plus 9. So here what we're going to do is we're going to check. And again, remember, I'm not allowed to cancel terms. I have to cancel factors, which means first thing I'm going to do is look at the numerator. When I look at the numerator, I see that this is a difference of squares. And if it helps you to factor one part and then the other part and then cancel out, that's fine. That's how I would do it. I see the top becomes y plus 3 times y minus 3. Then I look at the denominator. Now, if I'm being smart, I know I want something to cancel out. So hopefully this expression here has either y plus 3 or y minus 3 as a factor. And in this case, this is actually a perfect square trinomial, meaning it's going to factor into the same binomial twice, which in this case would be y plus 3 times y plus 3. And now I look and see, What are my like terms, or my like factors, my common factors? In this case, it's the y plus 3. So I cancel the 1 in the top with one of the factors in the denominator, and that leaves me with y minus 3 over y plus 3 as my final answer here. Again, can't cancel out the y's. I can't cancel out the 3 and the negative 3. So that would be my final answer. Are there ever any issues or things that we have to be careful about? Yes. If I look at number 8, we have 6 minus 3x over x squared minus 5x plus 6. When I say there's things I have to worry about, that means that I might need to do a little extra in order to make sure that I get the correct answer and that I get something which simplifies or cancels out. So if I look at the numerator, 6 minus 3x, I see only 2 terms. This looks to me like a GCF. So I'm going to factor out the common factor there, which is 3. That leaves me with 2 minus x. In the denominator, I have x squared minus 5x plus 6. This, since it's a trinomial, is going to be reverse FOIL. So we would go through our process of reverse FOILing, split it up into the 2 binomials, x and x. Same sign, they're both going to be minus. Factors of 6 that add up to 5, that would be 3 and 2. So here's the problem. When I look at the top and bottom of the fraction here, I do not have the exact same factor in the top and the bottom. If I look closely, I do see that there's 2 things that are similar, but not exactly the same. The 2 minus x and the x minus 2 are pretty close. So the question is, how can I address that? How can I fix this so that I get something that cancels? Well, what we're going to do is we're actually going to factor out negative 1. Because when I write b minus a, if I factor out negative 1, that really is the same as negative b plus a, or negative 1 times a minus b. And on the last case, we saw that we had 2 minus x. We didn't want 2 minus x, so we wanted it the other way around. So if I were to factor negative 1 out, say 3 minus x, this becomes negative 3 plus x, which in turn we would rewrite as x minus 3. So what we're going to do is we're going to factor out negative 1 to change the order. So if I go back to this problem here, rather than factoring out 3 in the numerator, I'm going to factor out negative 3. So that's going to make it negative 2. That's going to make it positive x. So that's going to then give us negative 3 times x minus 2 over x minus 3 times x minus 2. And now I can cancel out those x minus 2's. And that's going to leave us with a numerator of negative 3, denominator of x minus 3. Do the negative 3's cancel out? No, they do not, because they are not factors. They are terms in this case. All right, let's jump to our next example. So here we have a slightly more complicated example. Again, I told you want to always plan on factoring completely. So if you want to pause at this point and try this one on your own, go ahead. So now that you've tried this one on your own, hopefully, what we're going to do is we're going to look at the numerator here. And if I'm factoring completely, my first step is always to look for a GCF. So if I look at the numerator, 3x cubed plus 3x squared minus 6x, I do have a GCF. It is 3x. The leftover expressions, x squared plus x minus 2. In the denominator, I'm going to do the same thing. Look for a GCF. I would have a GCF for x cubed plus 2x squared minus 3x, just x. And then it's x squared plus 2x minus 3. So the next step is I can either cancel as I go along, or I can factor completely and then cancel out all the factors. So I'm going to do that in this case. I'm going to just keep going. And in the numerator, I have the 3x already factored out. The x squared plus x minus 2 should be a reverse FOIL. It should become x plus 2 times x minus 1. In the denominator, I already factored out the x. X squared plus 2x minus 3, also reverse FOIL. That's going to become x plus 3 times x minus 1. And now I'm going to cancel out my common factors. So I have the quantity x minus 1 in the numerator and denominator. Those cancel. But I also have these factors of x that I factored out. So I'm going to cancel those as well. And my final answer then will stay in factored form. In the numerator, what I have left is the 3 and the x plus 2. In the denominator, I just have the x plus 3. I don't have to write the parentheses for the denominator since it's not being multiplied by anything there. That would be our final answer. All right, let's take a look at one final example. So here we have z squared plus 2z minus 24 over 4z squared minus 144. Go ahead and try this one on your own first. All right, so let's take a look. In the numerator, I see z squared plus 2z minus 24, no GCF. However, I can reverse FOIL here. So I'm going to split it up into two binomials. We have z and z. Minus 24 means I'm going to have different signs, plus and negative. In this case, I'm going to have a positive 6 and a negative 4. In the denominator, I do have a GCF here. I'm going to factor out the 4. And that would leave me with z squared minus 36. So now what I'm going to do is I'm going to go one step further with the denominator. Numerator is going to stay what it was. But in the denominator, I already have the 4 factored out. And then it becomes z plus 6, z minus 6. And in this case, the z plus 6's are the common factors that cancel out. That's going to leave us with z minus 4 as our numerator over 4 times z minus 6. And that's going to be our final answer there. Can't cancel anything else out. So there it is. Again, hopefully this seems like a review for you. If you have questions, send me messages during the week or contact me on Schoology. Also, we'll have our weekly Zoom meeting that you want to check in on. So that would be another great way to get some help with this. You'll see in the agenda the assignments for this week are both IXL and another graded assignment, which I'll need you to show the work and submit it to me. So if you have questions, let me know. Otherwise, good luck, and I hope you guys have a good day.